Hi all, this is Mr. Yeager, Physical Science again. We are looking now at, let's get this started well. Okay. We are looking at now covalent bonding, okay? So we just finished up ionic bonds, where that's where electrons are being given or taken. And now we're looking at covalent bonds, Covalent bonds is where the electrons are getting shared. That's the key there. They're getting shared. Okay? So this is where we don't have any ions. Okay? There's no charges and no ions. Okay? The electrons are being shared. So with this lovely little picture down here, taken from Facebook community wired.com, wherever that is. Okay? That basically is just a little picture showing, hey, that, the first one's showing ionic, where one electron's giving to another one and they're bonding. The second picture, the yellow ones, are showing you covalent bonding. And the last is where there's a metallic bonding, where basically those electrons are kind of all over the place, but we'll get to that at the end. So we are going to talk about covalent at the end of this video. Okay? But we're again focusing on metallic we're talking at the end of the video. So what makes up a covalent bond? Okay? A covalent bond is formed between two nonmetals. Ionic is formed between a metal and a nonmetal. So now we don't even have any metals in this. So this is only going to involve atoms on the right side of the periodic table. And what's happening is, through sharing, both atoms are going to receive a full outer energy level. So what I have here is I have two fluorines. So if you remember how to do Lewis dot diagrams, this is where this comes into play. Okay? Both fluorines have 7 valence electrons. Okay? 7 valence electrons. They only need one more to be happy. Each one only needs one more. So what they do is they basically share that one extra electron between the two of them. Okay, it looks like a face, a mad face. All right? But they share these 2 electrons. So what it means is, if I can't really do it on the board, but it's basically like if I cover this one up and I count the dots around fluorine now. It's 1, 2, 3, 4, 5, 6, 7, 8. Like this one is technically with fluorine now, this fluorine. Okay? So that one has a full outer energy level now. If I look at the other side that I had to erase, this fluorine also has 8 valence electrons. Or not valence, well yeah, 8 valence electrons. It now has a full outer energy level. So by sharing 1 electron each, the one that fluorine is sharing, it still has, but it's now also receiving the other electron as well in a shared relationship, in a covalent relationship. So we're going to be sharing these electrons. So therefore, how do we then name these elements? Okay? How do I go from formula to name? Okay? How am I going to try to name these guys? Okay? So what we do is, okay? We first have to know that these are covalent compounds. Why are these covalent? Carbon, oxygen, non-metal, non-metal. Nitrogen, oxygen, non-metal, non-metal. Okay? So we're going to try to name these guys. All right? So let me go ahead and say what the names are. This one ends up being called carbon dioxide. Okay. This one over here is going to be called dinitrogen trioxide. So how is this already different from ionic compounds? Okay? It's really different because now I'm using these prefixes. I'm adding prefixes in front of the names to tell me how many atoms I have. Since I don't have charge anymore, there's no crisscross method anymore. So I can't use the crisscross method to go, oh, I need 1 carbon and 2 oxygens. That doesn't work. Okay? So therefore, with covalent, it comes down to these prefixes telling me how many elements I have of each. So some people think this is easier if they learn the prefixes because it's telling you how many atoms you have. All right? So the big thing is we need to learn our prefixes. Okay? So we need to be able to count up to 10 in prefixes. We need to be able to count up to 10. So here we go. 1, 2, 3, 4, 5, 6. All right, so let's do 1 through 6 first. The prefix for 1 is mono. Okay? Prefix for 1 is mono. The prefix for 2 is di, not bi, di, D-I. 3 is going to be tri. 4, tetra. That's usually kind of a new one, so a lot of people don't realize that. They want to say quad or something like that. Okay, so 4 is tetra. From 5 on, it's all about shapes. If you could think of a 5-sided shape, you know the prefix. A 5-sided shape is a pentagon, so the prefix is penta. 6-sided shape is hexa, so like hexagon. Okay, so we got 1 through 6 so far. Mono, di, tri, tetra, penta, hexa. Usually I tell people go home counting. Count with the prefixes. Mono, di, tri, tetra, penta, hexa. All right, but we're not done. We still have to do 7, 8, 9, and 10. Okay? 7 is a hepta. That one is probably weird. I usually put a star next to that one because people get hexa and hepta backwards. But hepta is usually a new one. 8 would be octa. 9 is nona. So that might be kind of a new one. And 10, a decade, 10 years. A decagon, decathlon. Deca is 10. So there's all your prefixes. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. These prefixes are telling you the number of atoms in the compound. So how do we put all this together? All right, so we have a compound here, chemical formula, C4H10. Okay? The first element will keep its name. And we will add a prefix for the number of atoms in that element. So the first element always keeps its name. The only little thing we got to be careful of is the first element, we never say mono. So mono is never used on the first element. We're only going to use mono on the second element if it's necessary. But the first element keeps its name, and you include a prefix that tells you how many atoms of that element you have. The second element, guess what? We're going to continue with the "-ide". Okay, we add the suffix "-ide" just like we did in ionic. And then you add a prefix to tell me the number of atoms. Any prefix, including mono. First element cannot have mono. Because when you're saying the element, we already know there must be one of them there. The second element, though, we got to be a little bit more specific. Okay? So here we go. Maybe we should name this one up here. So C4H10. So C is carbon. I have 4 carbons, so I'm going to put tetra in front of it. Again, it's all supposed to be one name, but you can kind of obviously write it that way. Tetracarbon. H, we didn't do that one. Hydrogen turns into hydride if it's the second element for IDE. That's how you add the IDE to it. It turns into hydride. So it's going to be hydride. But how many hydrogens do I have? I have 10. So the prefix for that is deca. So these are going to be long names. Tetracarbon decahydride. They're not going to be natural, rolling off the tongue names. It's telling you very specifically, I have 4 carbons and 10 hydrogens in this compound. Okay, is what I'm looking at here. And so that's how we're going to do all these. So next one. So what we got here, CCl4, this is Cl, not Ci. We're never going to do a compound with more than 2 elements. So this would be carbon. Do I need any prefix? No. There's only one, and I don't say monocarbon. I just say carbon, and then there's 4 chlorines, so this would be tetrachloride. All right, over here, I got 2 phosphorus, so diphosphorus. I keep the name of the first element, phosphorus. 5 oxygens, pentaoxide. Now technically, it should be pentoxide. When we do oxygen, we don't usually put 2 vowels next to each other. All right, but in physical science, I'm not going to be that picky about it. You could, as long as you understand it's 5 oxygens, pentaoxide, I'm pretty happy. Pentaoxide is the more technical name. What about water down here? H2O is water, but what's the chemical name? 2 hydrogens, so dihydrogen monoxide. Again, I would accept monooxide, but we should see that we don't need two O's. Again, we usually don't do two vowels in a row. Monoxide, okay? So I'm going to go drink some dihydrogen monoxide. What about this one right here? 5 carbons, that's pentacarbon. Decahydride. Okay, so there's the name of that compound. Questions? None? Knew it. What if I need to go from name back to formula? Name back to formula. I feel like this should be hopefully even a little bit easier. Again, I know you got to learn your prefixes, but it's telling you what to do. Write the chemical symbols for each element. Carbon, C. Fluorine, F. Prefix tells you the subscript. Tri, there's 3 carbons. Octa, 8 fluorines. Okay? So that's where we get this. We just look at the name, we got to know your prefixes. So we already did this. Dihydrogen monoxide, H2, monoxide, O. Trisulfur chloride, SCl, tri-tetra. Tri is 3, tetra is 4. Hexacarbon hexaiodide, C6I6. And pentacarbon, that's C5. Hepta is 7 oxide, O7. So again, if you know your prefixes, you should be able to do these fine. Write in the element, include the number of atoms based on the prefix. Okay? Last couple things. For metallic bonds, you just need some terminology you need to know here. For metallic bonds, these are obviously formed between metal and non-metal, or sorry, metal and metal. So we already went over metal, non-metal is ionic, non-metal, non-metal is covalent. So metal-metal bonds we call simply metallic. So 2 metals formed together. The big thing here with metals is they have what are called delocalized electrons. So that's an important term. If you see what bond is formed by delocalized electrons, it's metals. The idea is these metals almost like, it's like playing poker. I always use poker as the analogy. All these metals basically just toss in all of their electrons into this pot, and then they all kind of share them and stay together. Just like poker players stay involved in the game until they lose all of their chips. So if they basically, or they take them away. You could walk away from the game and take all your chips with you. If you want to be involved in the bond, you have to delocalize your electrons. Okay? They have to become delocalized. All right? We often say, okay, that metals form what's called a sea of electrons. All right? Because what happens is it's these metal cations, the positive metal cations, they're all attracted to these delocalized electrons. Another analogy a lot of people say is basically like you jump into a pool, it's a pool of electrons, and that kind of gathers all the people together. Okay? So metallic bonds, delocalized electrons, sea of electrons, these are key words that are only related to metallic bonds. So I think this is the last slide. Yep. How do you know what the type of bond you have? You have to look at the elements. So now, the tough part would be, should I use ionic rules for naming or covalent rules? You have to know both, and you can determine your first step for identifying a compound or breaking up how to name it or write it. Know whether it's ionic. That's a metal, non-metal combination. Covalent, non-metal, non-metal. And metallic, metal, metal. We don't do any naming stuff for metallic elements. So I'm going to get metallic bonds. We're not going to do anything special with that. We do need to know the naming of these two, so you need to know whether you should be using ionic rules or covalent rules. And that's what you got to be practicing quite a bit. That's it. Thank you.